Hey guys, I'm going to go over this first section of Biochem. Hopefully it is just a review for you. So I'm just going to kind of bounce back between my PowerPoint and my notes. Alright, so elements. We remember that there are the periodic table of elements, and just like you had in physical science, I am not going to make you memorize the periodic table of elements. You'll always be able to use that. But really in biology, we are concerned with a couple of elements. And those are... Nope. Okay. So I'm going to have to... You're going to have to bear with me. So it's schnapps that we are worried about, right? Which is carbon, hydrogen, nitrogen, oxygen, and sulfur. And those 6 different elements are really what make up most living things. We do have, obviously we have sodium and potassium and lots of other elements in there, especially the metals and the ions, but we really are concerned about these ones. And because they are all nonmetals, even hydrogen, so remember that hydrogen is over here, which looks like it's a metal. It really, they put it over here, but it looks like it's a metal. It's just over here because it's one valence electron. So because these are all nonmetals, they are covalently bonded. So that's just 2 or more nonmetals. So let's kind of look at what makes the different types of bonds and review those with you. So none of this should be new, right? So we have our nucleus, which is the proton, or we have our 3 parts of the atom, which is the proton, the neutron, and the electron. Remember that protons have a positive charge, neutrons have a neutral charge, and electrons have a negative charge. And really, we're concerned with the electrons when we're talking about bonding, because that is the glue that holds everything together. We're trying to get that 8 to be great. So we have 2 major types of bonds. We're going to talk about a third bond as well, too. It's the hydrogen bond. But we're going to talk about covalent bonds and ionic bonds and what those are. So I'm going to, because I thought I could draw, I'm going to just grab some pictures on the internet so that you don't have to be subjected to my horrible drawings. And let's get water, because we're going to talk about water a lot in this unit, so you might as well start learning about water. Alright, so here's water, and I'm actually going to rotate water so that you can see it like that. And so obviously water is H2O, right? And oxygen has 6 electrons, or 8, I'm sorry. It has 8 electrons. So 2 are here in the first valence shell, and then we have the remaining 6. But it's trying to make 8, because 8 is great. And so what it does is it starts grabbing some other elements around it, and because hydrogen has 1, it needs 2 hydrogens to make those 2 extra valence shells. So the covalent bond is sharing it, and you can see that these valence shells are actually overlapped right here and right here, and that's indicating that they're sharing it. So sometimes we'll really see, because remember they don't really float around these orbitals, they're like all over the place, right? Like zoom, 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 zoom. So sometimes the electrons are over here and they're filling up the 8 that makes oxygen happy, and sometimes oxygen lets it go and they're flying around here. and sometimes oxygen lets it go and they're flying around here. And so they're sharing them. But because of its characteristic properties, oxygen doesn't share them equally. It's like that 3-year-old that we talked about sharing things, right? So it has what we call a high electronegativity. And it's actually the second highest in the periodic table. Only fluorine beats it, so it's really, really highly electronegative. And when it becomes highly electronegative, it becomes that's what really counts as how well it shares. In this case, oxygen doesn't like to share. It's like sharing with a 3-year-old, right? And so they'll say that you can have the toy or whatever it happens to be for a little while, but it's really, you only get it for a minute or two, and then the 3-year-old wants it back, right? So you have to kind of understand that. Now, that doesn't mean that oxygen is an ion, because it doesn't have a true charge to it. So you will learn that in chemistry, that it really doesn't have a true charge to it, but it does have a really high electronegativity. So because that, what happens is it gets a partial charge. So sometimes if I looked at a water molecule, I would see this this negative charge on my electron, right? And if I came back and looked at it even a split second later, I might see that it has a positive charge. And then I see it a split second later, and now it's back to a negative charge, right? And then a split second later, negative, and then negative, and then negative. Because these electrons are they're moving from the hydrogen over to the oxygen. And so this has more electrons than it does protons, and this has less electrons than it does protons. So it gains a slight charge, but it really just depends on the time that you're going to look at it, and then maybe another time I look at it, it's got a positive charge, right? So the whole thing really isn't a charged atom by any means, but it does have a slight charge to it, and that has to do with its electronegativity, or how well it shares those electrons, okay? And because this has this highly electronegative charge to it, it's become something that we call polar. And really polar, it just means that the electrons are being pulled towards one element more than others. And that's just a characteristic property of oxygen, which is, it just is, right? So because of this, it gets a slight negative charge. And it's really, really important that you understand this concept of polarity, because polarity means that it can do a lot of really cool things. So when I go to dissolve things in water, they start moving apart because of these charges. So let's see what that actually really looks like. I just really noticed that looks like a little face in there. But let's see what's happening at a molecular level. So inside here, I have a bunch of water, right? And really, the water is oops. Let me try. Come on. Let me try. Okay, so really the water looks like this does, right? And I'm going to just draw a clean copy of this, right? So it's the oxygen, which has a negative charge, and then it's got the two hydrogens, which have the positive charges, right? So I have all these positive and negative charges floating around here. So let's see what happens. I'm going to shake some salt into there. And remember that salt is an ionic compound, which is even more polar. It's like as polar as you could possibly get. So salt is, table salt, is NaCl. And in that case, this becomes a positive charge, and this becomes a negative charge, and they become ions. And once they're ions, they always stay ions. They never stop being ions, so they always have a charge. Well, that's really cool, because when I put the water in there, or put this in the water, we know that opposite charges attract, right? So what's going to happen? This Na is going to separate, and it's going to get attracted to the negative charge, and the Cl is going to separate, and it's going to attract to that. So because it's polar, now I have Nas and Cls floating around in here independent of each other. They were able to dissolve. So it's a really, 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 really good it's a really good solvent. So I can put lots and lots and lots of salt in here, and eventually I'll run out of, see, I'm starting to already. I'll run out of oxygen and hydrogen atoms for those to attach to, and so I get like that salt sitting on the bottom, right? You know, so if I add more water, obviously, then I add more hydrogen and oxygen, and so some of that salt that's on the bottom can now free up, hopefully, and we can get that to break up. See, you can see the salts breaking up down there. So if I add more water, really what I'm doing is adding more hydrogen and oxygen for those to kind of go around, right? And so what's going on here is the same thing with sugar. So sugar, because it is C6H12O6 and it's got that O in there, it becomes a polar molecule, right? So sugar is C6H12O6. And because it has this oxygen in there, it also acts like a polar compound, right? So because it's polar, it has a charge to it. And so it's going to have a slight negative side. So the oxygen side is going to be slightly negative, while the carbon and hydrogen sides are going to be slightly positive. And so we're going to see the same thing, except for you wouldn't see it like this. It would look like a different compound, right? So you'd have another element floating around at you. So anyways, that is kind of a rundown on covalent bonds. I think I forgot to talk about ionic bonds. I did. So I'm gonna go ahead and stop this one, and I'm gonna talk to you about ionic bonds in another one.